All right, welcome back to another episode of Payathon. In this one, I'm going to talk a little bit more about classes, and as promised, I'm going to talk a little bit about class inheritance and how you can use it in order to, reuse more code, because that's the name of the game. So first off, we have this code that we wrote last week. And if I just run it, you can see we get a cube. We've created some functionality. It accepts some inputs here. And then, it renames. We're able to rename and delete things. So there's nothing too crazy going on here. But what I want to do is say I want to reuse some of this functionality. What if I don't want to create a cube and I want to create a sphere? But I don't want to have to rewrite this rename and this delete functionality. Well, what we can actually do is use something known as class inheritance. So instead of writing a class and rewriting all this code underneath that class, and all we're doing is really changing the CMDS polycube into CMDS polysphere, it seems very wasteful, the amount of code we have to copy and paste. And of course, it just compounds the amount of code we have to rewrite, the more complicated, the more functionality we implement in this class. So if we have like a ton of different methods that are related to this cube class, then we'll just have to copy and paste all that all over again. That doesn't make a lot of sense, because as we know in coding, the idea is to not have to rewrite or have to have, the same code show up over and over again. So how do we do this? Well, let me just delete this as a start. And what I'm going to do is actually create another class. So I'm going to create this class and I'm going to call this base poly, for example. Or maybe let's call it poly object. Okay, poly obj. And in here, of course, I want to inherit from object. So what we're actually doing here is we're inheriting the lowest level Python object, which is just the object itself. And again, if you guys don't know, this isn't required, this object section here. And these parentheses aren't required for Python 3. So if you're running Python 3 code, you can just do class poly object like that. But we're writing Python 2.7 still, so we need to inherit from object. So let's do that. And the next thing I want to do is actually just copy some of this code here, just move it up into this poly object there. And then now what I want to do is I actually want to make this a little bit more generic. So because this is just like a generic poly object, what I actually want to do is instead of creating a cube, what I probably want to do is just not create any object in this poly object. Okay, so we're just implementing the functionality, but we're not actually creating any object. And you'll see why in a second. So I want to create a new attribute. So I'm going to call this attribute name. And what I actually want to do is save this name here. So I'm going to put name there. And the name at the moment is cube, and I want this to be a little bit more generic. So I'll just call this poly obj. So we don't actually, create any specific type of object. We're just creating a poly object. And really, we probably don't even need to add this this parameter there. We can always say none if we wanted, but just for this example, let's say poly object. Okay, and we don't want to implement width because not all poly objects have this width attribute, so it might not be necessary. So let's remove that. That's very specific to the type of object, like a cube. I don't think a sphere would have width. It would have something like radius. So let's not have that parameter there for now. And instead, we can provide it just some quags, and what this does is it takes any sort of keyword arguments and it just stores it there. So we can have something like quags there. For now, I'll just leave that there, just so we can accept any number of keyword arguments, and we can decide whether or not we want to use them. But it's not going to error out if we don't provide any additional keyword arguments. And if we do provide additional keyword arguments, it won't error out because we're accepting a variable number of parameters there. Okay, so that's where I want to start with this. here I don't want this at all because we're not creating a cube. And instead of saying self.cube, what we can do is we can actually just have an attribute here if we wanted to say self.obj. But for now, I don't think we need that. So I'm going to leave that empty. Okay, so down here though, we have this rename, and at the moment we're doing self.cube and we're renaming this cube. So actually I do want to have this attribute, and I'm going to call this self.obj for object, and I'm going to do equal none. So what does this mean? We're just creating this attribute with no value, no particular value. Well, the value is just none. And instead of doing self.cube, instead of renaming self.cube, I want to rename the object, because we're not creating a cube specifically. We're just having this generic poly object there. So I'm changing all these specific cube things into just obj. And what we're going to do later is we're going to store the object that we do create, whether it's a cube, a sphere, whatever it may be, we'll store it under this attribute. Okay, so now we have the same functionality, more or less, as this cube object. The only difference is we're not creating the cube itself. So what I can do down here is I can remove all this code because we don't really need it. And instead of cube and object here, so we're inheriting from the base object, the most lowest level object in Python. Instead of inheriting from that, what I want to do is actually inherit the functionality from polyObject. Okay, so polyObject is the base class to this cube class. So what happens now is if I run this code, it's not going to work straight away. We have to modify a few things. But once I've modified it, what happens when I run this code is we have a cube that has all this functionality plus whatever additional functionality we add to this particular class. Okay, so we'll still be able to run things like delete, rename, and we'll still be able to access like the object name or the object itself. Okay, so what do I need to change down here? So now we have a width attribute here. So we're using it in this command, but instead of storing it in self.cube, remember up here, we have self.object. So what we can actually do is store this in self.object. But before we do this, we have to initialize the base class as well. So we need to initialize these attributes up there. So there's a special command inside of Python that we can use to initialize the base class. So that function is called super. Okay, so what that does is it will run all the base class stuff up there. So what we need to do is actually put the name of the class itself, which is cube here. And then we need to type self and then dot underscore underscore init underscore underscore. And we want to pass the name because this, when we initialize the init function, what this is doing is it's going to run the init function of the parent class. And we're saying, hey, we want to run init from the parent class of cube, which is polyObject. So it's going to run the init function in the polyObject class. So what does polyObject class take? Was just like any other regular function, we have to give it the name. Otherwise, it's just going to be polycube. So we can say name is equal to name. And we can also just pass it any number of random arguments, which we don't need because we're going to use width in here, but we're not going to use it in the poly object there. But if we had additional functions, additional parameters we need to pass, we can always, add it in there like that. All right, so now that we run this parent class's init function, it's going to have the name, it's going to have this self.obj, has access to all that good stuff, and it stores it in there. That's not going to really do anything much, but it's created this self.object attribute. So here we're just overriding that self.object attribute, and we're actually just storing the result of this polycube function inside of the self.obj. So that's where when we run rename, it's going to be able to grab that object to rename it. And also when we delete, it can grab that object to delete it. Okay, so this is basically how class inheritance works in a nutshell. You have a base class, which you inherit all the functionality and all the attributes from, and then we can, reuse that in a very simple way. We don't have to rewrite all that code, and we can just override certain attributes like this self.obj, for example, so that the functions there, these methods, will actually work. So the advantage of this is now if I wanted to create a sphere, well, before we actually do that, let's just run this code again and see if it works. Okay, so everything just worked exactly the same. Nothing's really changed from when we just had the single cube class. The only difference is now we have this generic class. So the advantage of that is if we wanted to create a sphere, what I could do is I could pretty much copy this code, just this small chunk there, not the entire thing there. Otherwise, if we didn't use inheritance, we'd be copying the same code again, a whole huge chunk of code. So this reduces the amount of code we have to copy. Here I can name it sphere. It's still inheriting from polyobj. And instead of cube, we can call it something like sphere as a default name. Here we want sphere. And down here, instead of self.obj as polycube, we can do something like polysphere. And I think polysphere takes a different kind of, like a different parameters. It doesn't have a width parameter, so maybe we can put something like radius. I think that's a valid parameter. Let's give it a shot. If it's not, we can try to figure out what the actual parameter for the sphere is. But let's just say 5 as well. And here, instead of just creating a cube, we can also create a sphere. So do something like bar is equal to sphere, name, maybe we call it Bob, the width, let's just have it 1. It's not really width, it's actually radius. So let's put radius there. Let's try it. And it works. So now we have a sphere called Bob. It's got a radius here of 1, and we can decrease that radius. So we can change this to, if we had 10, let's delete all that again, rerun this code. Now you get a really big sphere, radius of 10. Okay, we got the cube there with the the width of 5. And of course you can add additional parameters here. So we can do, let's see, height. We can also have height, and we can have depth. And you can even implement these ones as well, the subdivision with height, depth. You can add it all there. Or you could do something cool, like just accept a variable number of keyword arguments afterwards. And instead of doing it here, we can just take the keyword arguments and expand it into the cube function itself. So let's delete all that. Let's just comment out the sphere for a second so we can test out this cube functionality. So you can see width is equal to 10. Let's try to run this. You can see it still works because this this polycube command takes this width keyword argument, and I can add something like depth is equal to 10, and this should work too. So delete that, run this, and you can see it's also changed the depth. But this only works because this polycube command takes these specific parameters. So if I add something random like, car is equal to 10, that's not going to work, right? Because, yeah, you can see invalid flag car. That's because this polycube command does not take car as a flag. So that's just a neat little trick you can also use. You can just wildcard these parameters and just pass it directly to whatever function that you want to run inside of this init command. But yeah, this is class inheritance in a nutshell. And it allows you to basically take some simple functionality, reuse it throughout all of these different classes, and you can implement specific cube-specific methods. So I could say something like change width, and then maybe I can accept a width value, and then I can do something like self.obj like scale x or something. Oh wait, I'm not using PyMail, so I have to do something like cmds.set atom, and I need to set the attribute So I can format this name into there, and then I can do something like scale X, and I can set it to like width or something. You know, this is just an example of what you can possibly do. So you can create something like that. I could do foo.change width is equal to, not equal to, but change width 10 or something. You run it, you can see it's changed the width, but I'm just scaling. I'm not actually changing the width there. But you can implement it in such a way that it does change the width attribute there. But yeah, it goes to show you like what kind of different options you have available, and this can be specific to cubes, and you can do something specific to a sphere, like change radius, for example. So this is how you can write classes that inherit functionality from another base class, and this base class is a more generic description of what a poly object is, and then you can inherit that description as well as add specific functionality to things like cubes and spheres. But yeah, hopefully you learn a little bit about class inheritance. This comes in handy a lot for when you're writing UIs. For example, you can create a simple UI with, for example, maybe just like 5 buttons, and if you wanted to reuse that like simple UI layout, you can just wrap it as a class, and then you can use that class inside of another class, or you can inherit that UI's base functionality and then change the labels and stuff like that. So it's really helpful sometimes to do some sort of object-oriented style like this, but it's not always what you want to do. So that's a big caveat, that sometimes you think you need a class, but really you don't need classes. But when you do stuff like this, where you're trying to write some generic description of an object and inherit it, then that can get pretty handy, in certain circumstances. So yeah, it's definitely helpful to know classes and understand how classes work. But yeah, I'll leave that there for now, and hopefully I can talk about more of this sort of concept, maybe even show you guys how to do some sort of UI inheritance in a future video. So yeah, make sure you guys stick around.